to
Dr. Ismail Petrus, MA.
3, 2, 1.
Hi, hello. I am Tridevi Wulandari and my last student number is 004.
Hello, I am Nima Faiza Hamada and my last student number is 025.
Hello, I'm Gary Heriansa and my last student number is 056.
Hello, I am Putri Maharani and my last student number is 036.
Hello, I'm Arya Masatrio and my last student number is 60.
Alright, now our group will talk about sounds and shapes. We are going to discuss the interface between morphology and phonology. Let me explain to you the connection between morphology and phonology. The connection between morphology and phonology deals with how word structures or morphemes interact with sound patterns in languages. In language, morphology studies how words are formed using morphemes, the smallest units of meaning. Phonology, on the other hand, deals with the structure and organization of sounds in a language. The interaction between these two fields focuses on how morphemes can change or adapt based on the sounds surrounding them. Okay, let's go to the detail. The first is allomorphs and phonological variants. One way phonology and morphology intersect is through allomorphs. Allomorphs are variations of a morpheme that appear differently in sound but share the same meaning. For example, in English, the plural morpheme as has different allomorphs like as in cats, z in dogs, and is in buses. These differences in pronunciation are influenced by the surrounding sounds, making them phonologically conditioned. The second is phonological rules in morphemes. When morphemes are joined together, phonological rules often come into play. In English, for example, the past tense suffix ed is pronounced as the, or it, depending on the final sound of the verb. These pronunciation rules illustrate how morphology or word structure and phonology or sound patterns work together to create different allomorphs. This relationship also involves phonetic considerations like voicing, whether a sound uses the vocal cords, and point of articulation, for example, labial dental, alveolar sounds. Next is native and borrowed words. The phonological behavior of morphemes can differ depending on whether the words are native or borrowed from other languages. For example, borrowed words might have different sound rules compared to native words. This is why understanding a language's lexical strata, which refers to these layers of native and borrowed words, helps explain why some morphemes behave differently. To analyze these differences, phonetic transcriptions using the International Phonetic Alphabet or IPA help linguists represent how words and morphemes are pronounced. Reviewing the IPA is essential for identifying these subtle differences in sounds. Terms like labial, dental, alveolar, and voiced versus voiceless categorize sounds based on where and how they are produced in the mouth. Now, let's get to know the differences and the connections. Phonetics is about describing individual speech sounds. It is identifying their features and how they are produced. For example, the t sound in tap, tap, is a voiceless alveolar stop. And phonology looks at how these sounds function in a language, such as forming syllables, creating stress patterns, and interacting with other sounds in the context of words. In short, phonology involves the rules and systems of sound organization within a language. Meanwhile, phonetics focuses on the physical characteristics of sound. When we talk about the interface between morphology and phonology, we are focusing on how the structures of words influence their pronunciation and vice versa. Phonology provides rules that can predict how morphemes change in pronunciation, as allomorphs, depending on the surrounding sounds or the specific context they appear in. By understanding the intersection between these two fields, we gain insights into how languages work at the level of sounds and meanings, and why certain words sound the way they do.
Hello everyone! Today we are going to explore the predictable allomorphy in language, specifically focusing on how certain morphemes change their form based on the sounds that follow them. So, what exactly is predictable allomorphy? It refers to the systematic changes in the form of a morpheme depending on the initial sound of the base word it modifies. This means that the way a morpheme appears can be predicted based on a phonological rules. For example, the prefix in English. This prefix can take several forms, and which form we use depends on the sound that comes next. So let's break it down. First one is in. In, this is used before words starting with a vowel or alveolar consonants. For example, we say unalienable and intolerable. And the second one is in. This form is used before words that start with labial consonants. An example is impossible. And the third one is ill. This variation appears before words starting with L, like illegal. And the last is ear. This is used for words that start with R, such as irregular. Now, why these changes happen? This is due to a process called assimilation. Assimilation occurs when the nasal consonant of the prefix changes to match the point of articulation of the consonant that follows it. For instance, when in is followed by labial consonant, it changes to im to make it easier to pronounce. This process helps maintain the flow of speech and makes communication smoother. Understanding predictable allomorphy is crucial for grasping how language works. It reveals the underlying rules that govern the formation of words and how they interact with one another. This, this predictability allows speakers to form new words and understand their meanings without memorizing every possible variation. In conclusion, predictable allomorphy, as illustrated by the prefix in, shows us how morphemes can change from based on the sounds that follow them. This systematic variation is a key aspect of language structure, highlighting the rules of sound patterns and their impact on word formation.
So you have learned about predictable allomorphy, but in English, not all allomorphy is predictable. Let's start with past tense verbs. Regular verbs add a to form their past tense, like walk becoming walk. But many verbs don't follow these patterns. For example, sing changes to sang, win changes to won, come changes to came. These irregular forms don't follow a specific rule. Instead, both the base and past form are stored in our mental lexicon or memory. However, this pattern still influence how we make new words. For example, if we made up a new verb like gling, people might say glang or glang as the past tense, applying the same pattern as sing to sang or win to won. Now, let's look at the derivational allomorphy, or how verbs change when turning into noun with the shun suffix. Here are some examples. Designate become designations, prosecute become prosecutions, and define become definitions. We can observe some predictable patterns here. Verbs ending in "t" often change to "sh", as in prosecute becoming prosecutions. Verbs ending in "p" like resolve drop the "p" in the noun form like in resolve becoming resolutions. And verbs ending in "the" and "the" becoming "j", like in decide becoming decisions or circumcise becoming circumcisions. This process is called palatalizations, where sounds like "t", "the", and "z" shift to palatal sounds like "sh" and "z". However, not all changes are predictable. For example, combust becomes combustion, but impasse becomes infestation. Accuse become accusations, while propose become propositions. These exceptions show that some poems must simply be memorized. While processes like palatalization are predictable, other changes follow no clear patterns. In conclusion, unpredictable or partially predictable allomorphy shows how some shape word forms in different ways. Some follow phonological rules, while others are stored in memory as exceptions.
The next topic is how to analyzing allomorphy. In this section, we'll take a close look at another language and see how morphologists go about analyzing allomorphy in a language that's unfamiliar. In the example from Tagalog, Philippine language, we are looking at how verbs change when a prefix is added. Verb root ana, actor focus mangana. Bakya, mambakya, dukot, mandukot, gulo, manggulo, hiwa, manghiwa, kailangan, mangailangan, ligaw, manligaw, manhit, mamanhit, not, manot, pili, mamili, sakit, manakit, takot, manakot, walis, mangwalis. The focus here is on the prefix used to form what we call the actor-focused verb. The prefix isn't always the same. Sometimes it's mang, sometimes man, and sometimes mam. This change in form is an example of allomorphy, where the same morpheme appears in different forms. Next, K patterns. First, nasal assimilation. The prefix mang, man, or mam changes based on the first sound of the verb root. For example, mam appears when the verb root starts with a B or other labial sound. Man appears when the verb root starts with an L or D. Mang appears when the verb root starts with a G, H, or W. And next, what's happening to the consonants? In some cases, the first letter of the verb root disappears when the prefix is added. For example, instead of saying mampili, the P drops out and it becomes mamili. Next, rules. First, nasal assimilation rule. The nasal sound in the prefix like M changes depending on the first consonant of the root. For example, mang changes to mam or man depending on the verb. Second, deletion of voiceless consonants. If a verb root starts with a voiceless consonant like P, L, or K, the consonant can disappear when the prefix is added. And how do linguists decide which form is the basic one? To figure out the underlying form of the prefix, the form before any changes happen, linguists look for the version that appears the most in different situations. In this case, mang is the most common form because it can appear with several different types of verb roots. So it's likely the best form. The other forms, mam, man, come from phonological rules that change mang depending on the root. In short, the allomorphy in Tagalog verbs follows predictable patterns of nasal assimilation and consonant deletion. The rule explains how the verb forms change, and by identifying the most widely used form mang, we can better understand how the different versions of the prefix are related. This approach helps linguists figure out how sounds interact with each other and change in different contexts. Next will be explained by Arya.
And now we are going to dive into the concept of lexical strata. What exactly are lexical strata? Lexical strata refer to the layers within a language's lexicon that exhibit different phonological behaviors and morphological rules. Essentially, these layers show how words and their parts like suffixes interact differently based on their origins and usage. Let us start with English. English derivational morphology has two main lexical strata, native and non-native. Native suffixes like ness in happiness can attach to both native and non-native bases. Non-native suffixes like ity in activity typically attach only to non-native bases. For example, the suffix al can change architecture to architectural, and ity can change active to activity. These suffixes often change the stress pattern of the base word. Now let's look at Dutch. Similar to English, Dutch has native and non-native suffixes. The native suffix heid means ness, and it can attach to both native and non-native bases, like blindheid means blindness and diversheid means diversity. The non-native suffix itheid means ity, and only attaches to non-native bases, like diversiteit. And for the last, we have French. French suffixes are divided into popular and learned categories. Popular suffixes like age in doublage means doubling have evolved from Latin through regular sound changes. Learned suffixes like air in circulaire are borrowed from scholarly Latin and attached to learned roots. For instance, angel becomes angulaire with a learned suffix, and pupil becomes pupillaire with a popular suffix.
Don't you want me like I want you, baby? Don't you need me like I need you now?